So this demo actually shows very well about the powerfulness of this kind of a pipeline and all the underpinning algorithm supported by our runtime systems. And we use that in a lot of our projects. Because that we're running a little bit late, so I will ask you that any questions before I go to next session. Any questions? Please.
For the visualization, the prompt is actually you are directly in the same time you are updating the data and then you just show the data in the prompt.
Yes, it's in real time.
And the prompt is running on the cloud.
Promptviz is a visualization tool running as a client, application.
In the cloud system.
It's not necessarily in the cloud. You just run on your desktop.
Okay.
Yeah. Any other questions? All right. So this is a hands-on session, but I mainly want to just illustrate how we do the programming of iterative MapReduce. And I'll leave some assignment for you because this slide is available online, has every details of the instructions. So we're already familiar with the k-means algorithm. But how do we, in programming level, understand to program using this kind of runtime systems? So basically, we want to partition the data into different chunks. And this is illustrated by the 3 partition blocks, and I omit in the middle. And the invariant data is the central vector. Its varied data is a central vector, and that will encapsulate all those kind of intermediate steps of the cluster centers. And at the end of each iteration, we get a global reduction to find the cluster centers, and then we rebroadcast after each iteration to all the related to map tasks. We continue this cycle again and again until the convergence of the final result. And that is the way we do this k-means clustering parallelization. If you look at this implementation using MapReduce, they clearly separate into mapper stage and reduce stage. In mapper stage, basically you have a key function and calculate Euclidean distance. And reduction function is basically you summarize all these kind of intermediate cluster centers. So with these steps, you go on different iterations, you can finish the computation. So as we understand, MapReduce mainly is how you utilize key value pairs. So in here, initial key value pairs that the value is the file. In the intermediate key value pairs becomes the key and the vector space of a centroids. So you have the reduction get ultimately the result of the cluster centers, exactly what we want. So I will not go through the code walkthrough, but I will just quickly show you that the structure of this Twister software. And this software actually is packaged in your VirtualBox if you want to follow up with the running of these applications. And there are several directories, including Twister, and under Twister have bin and the k-means applications and ActiveMQ. These are the packages. So you basically download the VirtualBox. I presumably already installed that in your systems. And what you do is that you start ActiveMQ and you start Twister, and then you try to copy the files from the common data directory to the created k-means directory, and you partition those files and create the partition file. And then you basically run Twister. It's very simple, just the 4 or 5 critical steps. So hopefully that after this class, you'll be able to test it by yourselves and get a feeling for this kind of a programming model, how to use them. So with that, I end my talk. What I want to acknowledge is the Salsa group is supporting our work in these areas, and we're funded by Microsoft, Indiana University, NSF, NIH, and the FutureGrid. Thank you. I would like to take questions, but otherwise you can also send me email.
You have a question over there? 2 questions. Yes. Compared to Hadoop and Spark projects. So what is inherent novelty in this iterative MapReduce? Is it, what I understand, is it optimizing the data shuffling across different nodes? So that is the main theme?
Yeah, that is a very good question, because I listed actually at least a dozen iterative MapReduce framework, and I see that there are more kind of such system is coming up for the obvious reason, because of data mining, data analysis is a very important area. People try to solve their problem and support their applications. So in specific to your question about what the difference between Twister, Spark, and Hadoop, is that Hadoop is really extension built on top of a Hadoop, while Twister and Spark are standalone applications. We built from scratch. Has nothing to do with Hadoop at this moment. And Spark is actually optimized for in-memory storage, in-memory fault-tolerant support. We're not supporting that. But on the other hand, we're optimized for supporting data-intensive problems, because I illustrated by the image processing is a huge intermediate data size. Normal iterative MapReduce framework cannot handle. So there are a lot of details and subtleties that they're quite different kind of choices. But ultimately, you can think about iterative MapReduce is basically try to solve iterative solver problems at system level. But how do they do that? Optimize for specifically what kind of performance for applications is really individualized for specific framework. And also another trend is that all these kind of functions already, for instance, at Spark, they also have a higher language support and other kind of areas, and we're also looking into that.
There are any additional questions behind the questions?
So the question is that if there are further questions, then can I answer them? Definitely.
So the other side.
Yeah. Any side?
They want you to repeat the question.
Okay.
Not the answer.
Okay.
Sorry.
So any question from remote side?
UCLA has a question.
Okay, please go ahead.
Okay, one of the advantages for the Hadoop and our method today we emphasize is its fault tolerance. So my question is, it's okay one of the nodes to die and Hadoop will continue to work. What happens if the master node itself dies?
That is the issue, is so-called single point failure. So at this moment that we would think that the chance of the master node die is really very rare. But on that hand, you really can have a backup server that you can switch. So this is, the current status. Very good question. And also tomorrow that Selena will talk about Twister for Azure. There is some work in the area. They try to make it decentralized iterative MapReduce to specifically address this issue. All right. I'll be happy to take questions by email and other channels. Thank you very much.